understood about all the model training part, that how to train the YOLO model for object detection on our own custom dataset, right? We also know about that how to annotate the dataset properly, how to label it, how to do the auto labeling operation and other things using the tools and platforms like RoboFlow. Okay, but we actually missed one very important point, and which is model monitoring part. Now let me tell you that why it is a very crucial step in order to like monitor your model. Because suppose if you're actually training a model and you are working in some industries guidelines, okay, you need to follow some guidelines, right? And suppose if you're not using any monitoring tools, then you keep on like updating the weights of the model, training it, right, and saving it somewhere, saving it into the artifacts. Okay, artifacts is like a small bucket where you will save your model, right? Then there will be a time come where like you need an exact perfect measurement of which of these artifact has the best model. Number two is that which of those artifact has taken a very less GPU. Okay, then which of those artifacts are basically more efficient in terms of accuracy, precision, recall to give the best detection. Okay, so you need to counter each and every record. Okay, and you do not have any systematic way of just looking into it. Okay, you just need to look iteratively just to find out your best.pt file. Okay, now that is where the model monitoring tools comes into the domain. Okay, and why it is needed is because the model tools like the monitoring tools like MLflow, okay, the WanDB, okay, these are basically a post training analytics tool. And why is it needed? Because suppose if you're actually training your model, right, on a big chunk of data, and suppose if the data itself getting updated like weeks after months after years, the data basically keeps on updating, right? Now the point is like how do you actually monitor the trend? Okay, then how do you basically save the model? Okay, how do you basically segregate the model according to the use cases and other thing? Okay, that is very important. That is why the entire pipeline, right, at the very last step, model monitoring is very important. Okay, so that you as your engineer, right, you should know that which model actually performs well for which kind of a task. Okay, so I hope you get it. So from now we will carry forward this video that is just a continuation of the last video where we have left the training part, where we have actually inferenced the training model, right? After that we just need to understand about this. The very last and crucial step is model monitoring part. Okay, that while basically training our model, do we have some like flexibility so that we can actually visually see our training part? Okay, we can actually see that how much inferencing time it is taking, how much GPU does it need, how much compute does it need. Okay, so what is the cost of survival and other things. Okay, so if we can actually like see all these things, then it would be far more sufficient for us to go and look into the model in very detailed manner. Okay, so that is why model monitoring is needed. Okay, so the tool that I'm supposed to use from now is basically I will be using the MLflow and I will be using the other tool which is like WanDB. So these two tools are very like, there are other tools as well, but these two tools are basically like hugely like expanded in the industrial domain. That's why. Okay, so without wasting time, so again we will be moving into the MLflow part first. I will tell you, I will show you that while training the model, how you can actually like visually see your model, right, while training part. Okay, so suppose if I have a data, okay, if I keep on training my model on set of custom data, okay, so like will that model is getting saved in some artifact, and if so, then what is it like the more accuracy matrices will I get? Okay, how can I basically see it, right? How can I actually go and see the experiments that I have done and other thing? How can basically I see the logs and other part? Okay, so we will see everything in detail. Okay, so let's move into the implementation part and I will show you about the MLflow part as well. Okay, so first we will begin with the MLflow and then we'll be moving forward to WanDB. So yeah, thank you. Okay, so now let's try to understand about this MLflow part. Okay, so that is basically the last part of our model training phase. Okay, so once you actually train your model, right? So there is two ways that while training your model, you basically want to see that how it is getting trained. Okay, then like how much compute it is actually taking, and after training, let's say that experiment by experiment, right? So for each training, you will be giving the experiment name so that later it is easy for you to just go and take a record of the model. Okay, that which model at which particular date or time you have basically trained it, so that you can basically export it. Okay, so all these things will be done by the MLflow. So let me just go through the Ultralytics MLflow documentation. So this is basically the Ultralytics MLflow documentation. So they have actually like integrated the MLflow with their own set of libraries, which we are going to use it now, right? So as you can see that MLflow components, so there are like, you can actually do the tracking, you can actually like save the model artifact, there is a model registry as well, and there is the projects wise, you can actually able to do it, right? So again, these are basically the feature that it is providing. So first of all, it is actually providing the metrics log. Okay, all this logging which is actually needed by training and post training. Suppose you wanted to see any kind of a matrix, you can actually see that thing. Then there is a parametric logging and there is an artifact. Okay, setup is very simple. So first of all, let me go to the setup as well. Okay, so let me just open any IDE. Okay, so let me just clear this out. Let me first activate the environment, right? Let me first activate the environment. So what I do is that source, I know that because we have already done these things, environment setup, right? So this I have set up the environment part, right? Now next what I need to do is that, let's say that I need to install the MLflow. Okay, so for installing the MLflow, again I will refer to the documentation, which is like this one, right? So in order to install the MLflow, first of all I will be installing the MLflow using a pip package, right? So let me go there and let me just do this, right? So what it will do is that inside my environment, it is basically like try to load the MLflow. Okay, after loading the MLflow, the one very important thing is that suppose if you are actually like training the model and everything is completely, let's say, offline, okay, and you wanted to like see the all these matrices and artifacts in your local system, right? So you need to first open the server, okay, to open the MLflow server into your local system. Okay, so in order to like initiate the server, you need to set up this command, which is this one. So this is basically the MLflow backend server. So it will try to load the MLflow server into your local system running at some particular port, okay, so that it becomes easy for you to trace down everything locally, right? So if I just go and just press it here, so as you can see that my MLflow server has been started at my local host with the port number of 5000. So if I go and click there, then this is my server where it is starting. So let me go there and follow the link, right? So let me open it in Chrome, right? If I go there here, so this is where my MLflow server has been started. Okay, as you can see that it has something called as experiment. So I will tell you each and every detail of about it, like what it is. Then the other thing is model and the other thing is like prompt. Okay, so before like losing the time, let me just go and try to open some other terminal. Okay, so that we can start building the or training the model. Okay, so again let me like do the environment part. Right, going to the same location, there I will going to run the MLflow. Okay, so as you can already aware, right, these things, right, that how to basically train the model, we have seen it in our collab implementation part, right, that how do we basically train the model. So we have like imported the model, okay, then like we have imported our pre-trained model, or let's say the post-trained model, we just wanted to give you the location, okay, and then we will all set for training part. Okay, and we have done the training in last lecture, like the entire lecture we have covered about how to train the YOLO model. Okay, so I think I'm not repeating that part. The next part which I'm supposed to tell you is that how do you basically integrate the MLflow, okay, in your training environment, okay, in your training code. So what you need to do is that from the Ultralytics, right, you just need to give few permissions so that whatever the model after training, you know, right, like post training, then my model is getting saved, right? So my model is getting saved in somewhere like ML artifact, right? So it is saved in two categories. So one is like best.pt and the other thing is like last.pt. So we have done, we know about these things, right? So we just need to give, let's say that I wanted to train my already post trained model based on my custom data set. So last data set that I have taken is PP data set, right? I have labeled it, I have trained the YOLO pre-trained model, okay, on that PP data set, and now it is getting trained, okay, and it was trained and it was actually giving the good result, okay, and we have actually tested and we have inferenced it also, right? So these two models I have, right, post training, I have the best.pt, I have a last.pt. Okay, now let me train it one more time. Okay, let me train it one more time just to show you that how after the integration of MLflow, so how does it basically behave? Okay, how can I actually monitor my model? Okay, so I will pick up the same thing, which means that I have picked up the base.pt model. Okay, instead of pre-trained model, I have picked up this model, right? .pt model. Any .pt model will be survived here, right? Then again, I will be training the model and I am going to give these things, right? So the first one is the same thing, right? I'm supposed to give my YAML file, right? So for now I am just training it for, let's say, 3 epochs. Okay, then this is my image dimension. Okay, then this is the batch I wanted to take. Okay, this is basically the patience level. Okay, which means let's say that if the patience level is 50, right? So what does that mean? It means that if somehow there is an interruption, okay, so it will just revert back at ping 50 times. Okay, if it is not getting a good like connection, okay, or a good receiving signal, then it is going to stop it, right? Then again, so if you wanted to plot, so I'm just making plots equals to 2. Okay, so that if I just like try to plot result dot plot, I hope you know the result dot plot, then you would able to plot the result into your image with the bounding box. Okay, and now the device is basically MPS. So MPS is basically what? MPS is basically like I am running it into my Mac system, right? So it's basically, so I need to give the MPS. Suppose if you're running it in GPU, so you need to give CUDA, okay, or any GPU dependencies that you have. Okay, and then these are my training phase. Okay, so I know that up till line number 17 to line number 34, I definitely know that you won't be facing any error. Okay, now you just need to add few things. Okay, the one in one terminal you have actually like initiated the MLflow server. Now what you need to do is that you need to give the server location here. Okay, so this is basically you are actually like you wanted to give the MLflow tracing URI. What is tracing URI? So that these model that you are actually like training, right? So that has to be like saved as an experiment name of PPE detection training. So this is my experiment name, which I am actually like doing all these things, right? And this is basically the MLflow running library name, okay, which is like the YOLO V. Let's say that we are actually training on YOLO V8 model, right? This is why YOLO V8 PPE training. Okay, you can actually try to give any other thing. Okay, and then let me just give other thing. So let me just give YOLO V8, let's say testing. Okay, and then let's say PPE detection training, PPE detection, let me give MLflow. Okay, so these two things I have already changed it, right? And then from the setting which I have imported it from the Ultralytics, so I have just wanted to make MLflow equals to true, so that my server could know that this the current code, right, which I am supposed to run for training phase, right? So it is connected, so it will going to connect to my local server. Okay, so that which is running on this port. I hope you get it, right? So while training phase, whatever the things that I am training, it will going to store or send every information in my local server running at port 5000. That is why I'm just running like that is why I'm just like denoting these point here, right? And again the same thing, right? I am just printing it here, and let me just initiate the training so that you would able to get it. Okay, so I'll just save it from now, right? And let me just initiate the training, which is like python.py. Okay, so as you can see that simultaneously my training has started, but also you will see that all these things are getting captured and reflected on my MLflow server, so that I could able to know other detail as well, right? So let it first train. Okay, so I am just training it for 3 epochs, because just to show you that how MLflow is actually registering everything, right? So after training, let me again like come back to the same video, and I will let you know that how is it all reflecting. Okay, so till now it is, as you can see, that it is basically training. Okay, so let's wait. See, as you can see that this part, right? So this part is basically my new experiment has been created, which is like PPE detection MLflow. What does that mean? It means that, let's say, in the same file, if I could tell you, right? So this one, the PPE detection MLflow, which means that experiment by experiment, which means this is my, let's say, current environment. Okay, this is my current experiment name. Okay, on which I am training my .pt model. Okay, I have already like these are my .pt model. Okay, now what else do I need to do? Okay, so I need to give the experiment name. First of all, I need to give the experiment name. After the experiment name, I need to give the MLflow running environment name. Okay, why is it needed? Because currently it is actually running in this experiment only. Okay, next time if I train it, right, I can give some other experiment. Okay, next time if I trained, I can give some other experiment. In this way, I will be having a good registry over here. As you can see, for now, for now, this is the current like implementation which is like running. Okay, if you go to the YOLO V8 testing part, if I go to model matrices, so as you can see that this will keep on updating, right? This will keep on updating because it is training now, right? So it will keep on like updating. If I go back, if we see this part, right? So this has been like started 8 minutes ago. Okay, so let me come back to this after training, once the training is completed. Okay, so that you could actually better understand this thing. Okay, now let's see that whether my training has been completed. I think the training has been completed. Yes. So my training has been completed. Now let's revert back to the same server, the MLflow server, and check that what are the matrices that I'm getting. Again, so this is actually running in my local server 5000, right? Where my all those model will be in this experiment, which is like PPE detection MLflow. The experiment name, which I have already pre-decided before training, right? So this is my PPE detection, and if I go and see it here in the model matrices, so you will see now that these are the matrices that I will be getting. Okay, so what are the matrices that we are getting? We are getting some LR, like then some other matrices. Okay, the like the mean average precision, the recall while training. Okay, these are actually the bounding boxes loss, the class loss, another loss. While validation loss, we are actually getting so there are so many things, right? So we are getting, and suppose system matrices, traces. Okay, and these are basically the artifacts, right? So if you could see, you can actually like try to download it here. Okay, so see how well can you see the beauty of it, right? That how well it is like proposed. Okay, how well it is like proposed in experiment wise. Okay, see all these things, right? So you don't need to like create everything explicitly. Okay, these all these things, this graph and everything, so it's very helpful for anyone who wanted to like a very smooth switch while the model post training part, right? So MLflow is like a really interesting in that purpose, right? Because this I have just like train it for, let's say, by giving the experiment name at PPE detection MLflow, right? Now suppose that there is a requirement come in your team, right, where let's say that you get the data. Okay, you get the new data and you want it. So if superior tells you that you want to like retrain your model, okay, then of course you will be taking the last.pt file. Okay, and then you will be training on your own custom data. Okay, and you want to like give it some other experiment name. So let me just train it in that way also. I think that would be good, right? So in the experiment name, let me give this experiment name as, let's say, version 2. Okay, that like someone comes in your team and he wants you to do the retraining again, and then you wanted to like save it in version 2. So what you wanted to tell that, okay, you can actually do it because you have this all this registry part. Okay, then again you will again restart the training. Okay, so let me just restart the training. Now let's see what will happen. First it is actually starting the MLflow server. Okay, now let's look back to this one. See, this is your version 2, this is your version 1. Okay, this is your earlier version, this is your version 2. So is it kind of something like a version control of your model, right? Where this is your like the last training phase reflection. Okay, and this is like your current training phase which is actually running. Okay, which is like currently in training, right? So in this way you will get so many things and so many variety of version control, post training version control as well. Okay, where you have a lot of model registries and other things, right, that will be present here. Okay, same like this one, right? So inside this, let's say that these are the runtime that you are given, right? So you can actually change the runtime as well. So let's say in the same environment I want to change the runtime, right? So I can basically train it, like change it. How? Just go to this code and just you can just change the runtime. Okay, so like suppose in the you wanted to keep the previous version itself, but only you wanted to change the runtime. So you can basically change the runtime, and for each runtime you will be having a different artifacts. Okay, so in this way you can basically like try to see the model in a very clean way. Okay, so that you could possibly know that what are the other things. Okay, because it is still in training phase, so it will keep on updating, right? So this is like the main agenda of showing you the MLflow part. Okay, that how everything is getting like crisp and concise way, right? And that I don't need to like confine myself to do any extra unnecessary things, right? So I don't need to like create an extra pipeline just to manage everything. Okay, all these things getting managed by the MLflow itself. So I know you get the basic idea about the ML flow part, that how to integrate it into the code using the Ultralytics repository, because Ultralytics has done so many phenomenal changes in when it comes to the integration of ML flow. Okay, so it's nothing. Again, I will just reiterate to the code so that you would know by yourself, right? See, this part of the code you already knew it, right? That how to basically custom train your model. You just need to add. You just need to start one ML flow server in your backend in the other terminal to the same environment. Just open the other environment. Okay, give the artifact, or let's say the experiment name and the runtime name of the experiment of your choice, okay, running in this MLflow server, and then you start training as it is. Okay, and then all this training keeps on recording in your predefined experiment name. Okay, if you wanted to change it, you can actually change it, so that next time if you do the training part, it will going to record in the some other experiment. Okay, so in this way you will do lot of hands-on demo on this ML flow. Okay, and you can actually like have a very clean way of storing the artifacts. Okay, so yeah, so the next video which I'm supposed to tell, okay, so that will be mostly related to WanDB. So WanDB is also doing the same thing, but I preferably choose WanDB because it may have a lot of different graphs and other phases. Okay, so you can choose by your own choice. So let me again go again to the WanDB, and then at last I will tell you in the conclusion section that when to use which one, like when to use what. Okay. Okay, so now let's move to the implementation of WanDB. Like how do you basically like try to integrate your WanDB into your model monitoring stage? Okay, you just need to do anything. This is not a rocket science. You just go to the Ultralytics integration part. Okay, and then you will find somewhere weights and bias. Okay, inside this weights and bias, you will get all the documentation. Even like you can actually refer this video for in-depth detail, right? So let me just go and create a profile. I have already created a profile, so it's like go to weights and bias. So inside the weights and bias, if you go, fulfill the login and sign up stage, and then just go to your profile here. You will get API key, copy this API key and just paste it here. Okay, so how is it different? Not in a very much different. So it's like, for example, the earlier one, right? So earlier one, you are actually running the model monitoring stage, okay, into your local system, which means that you have like try to first of all like start the server, okay, running at local system at 5000 port. Okay, your ML flow and integration part, right? Now here what WanDB do is that like WanDB actually provide all these monitoring stage, okay, your graph, your accuracy matrices, okay, your other compute loss and everything, okay, your artifacts details and all these things, your experiments and other things, right, according to your model, whichever comes in your model monitoring pipeline, right? So everything will be running into the WanDB cloud. Okay, so for like connecting with that cloud, okay, because that cloud is actually not running in your local. Okay, so you need to provide this, you need to do the login step. Okay, so that is why you need to provide the API key here. I hope you get it right. Now what you need to do, again the same thing, like from importing the YOLO setting model, so you just need to like do this WanDB equals to true. Okay, so that you actually give the permission to connecting with your cloud server. Okay, then again you can actually like proceed with the same stage. Okay, so let me just change this name, the best.pt file name. Okay, now what I'm supposed to do is that I'm supposed to change the name here. Okay, let me save some other name as well. Okay, let me give this file ML file. I have given the ML file. Let me give the projects Ultralytics demo. Okay, and let me give something name. Okay, so I'm training YOLO V8, right? YOLO V8 model. So YOLO V8 testing version 3. Okay, the version 1 and version 2 we have already tested it in via ML flow. Okay, so this is basically version 3, and again the same thing. Okay, you know exactly the same thing, right? You just need to give the permission, and that is why like the Ultralytics has made our task so easy. Okay, we just need to like put this detail, give the permission, connect it to the cloud, and then just run the training stage, training 5. Okay, so which means the WanDB monitoring, and press enter. Okay, and you will see that the training started, the training has started. Okay, once again, yeah, the training has started, and if I just go to this one, so let it just run for one epoch. Okay, and what is my this name? So my project name is Ultralytics demo, and my WanDB run name. Okay, just like the run name you used to get in ML flow, so the same thing you will be getting here. The run name is YOLO V8 testing version 3. Let's go to the WanDB. and let me go here, right? Let me go to profile, projects, see Ultralytics demo. Okay, earlier I used to do so many things, right? I have just like, while fine tuning the model, I have just used this one, this one, this one. Even for making the RAG course, I have just used WanDB, right? So or showing each and every benchmark. Okay, it's the same thing. I basically like their platform. That's why it's so flexible. So yeah, if I go to this Ultralytics demo, which I have just created now, where my like the pipeline is actually running. So if I just go to this version, so you will see that initially it will start making. See, so first of all, it is like it will show my GPU usage, my GPU temperature, my GPU utilization, the system power usage, network traffic, disk IO utilization, everything. Okay. So if I go to overview, these are my overview, which means that these are my configuration file. Okay. And if I go to logs, so these are basically my logs. Okay, whatever the things which is actually training now, so this is like the log is, it is reflecting it, right? So currently like it is running on 1 out of 2 epochs, right? And let me see what are the other things that you can get. So first, let it first run. Okay, let's train the model. Let me see that up to which epoch I am training. So I am training till 2 epochs. Okay, so it won't take much time. So after training, I will again continue this video and show it to you everything. Okay. Okay, so I think now the training has been completed. Let me check. Okay, looks like the training has been completed and it has mapped to the WanDB cloud system. So let me just go to the cloud and see. Okay, let me just go to my workspace. So overview projects, Ultralytics demo. Inside this is my all these things. Okay, let me just minimize this. Okay, see, so inside this, right, if I just go here, so you will see all these compute matrices. Okay, all whatever the compute matrices that you actually needed in terms of all this temperature, GPU utilization, and system power, and like network bandwidth and other thing, you will get it, right? Now let me go and check this one. So this is basically my validation loss. This is my training. This is my model, matrices, and media. Okay, and these are basically the media. Okay, see, there are so many things. Okay, that is why I'm very much like curious about like using the WanDB. Okay, so if you see, you will get the detection on training batch file. Okay, and then you will get something like this, right? So similarly, this is basically my batch one. So this is like detecting my trained model on set of batches, like set of images. Okay, and then it is actually detecting it with the class name. Okay, in this way you can actually like try and download this image as well. Okay, so you can just download it here. See, I can basically save it, right? So now let me see what are the other things is there. Okay, system is there, curves, what is there in the curve? Inside the curve, see these many good graphs that you will get. Okay, you will get a recall confidence graph, precision graph, and other things, right? You will get these things as well. See, say it's really looking nice, right? So if you are doing the research work or writing any research paper, if you're training the model and like try to monitor it using a WanDB, that will be a good source of your implementation, right? So these are like basically the timestamp. There is one more thing I wanted to show you. Okay, so let's say that if you wanted to create a report, okay, you can basically create a report as well, right? Report and share the report of your entire experiment matrices, right? So just go to the report section, just create report. Okay, just give the report name. Let's say I'm just giving the report as, let's say, post training analysis. Okay, post training analytics. Okay, if I just created this report, and let me just go to this project. Okay, my this one, can I add this thing into my report? Add to the selection report. Yeah, just add it into the report. Which report I have just created? So post training analytics, right? Add to this report. Okay, and now let me add some other thing as well. Let me add some other graph. Okay, this one, add to the report, add to the report. Right now, let me add new report. Let me add everything. Okay, let me add everything into the report. Media, these things, right? Create a report. let me write another name. Okay, analytics report. See, are you getting this right? So everything is now like your entire analytics, right, is now like converted into a one single page report. And I think this is the great way to showcase your the ML project, right? Because I think I will feel much more happy if some candidate or some practitioners come not just by training the model but by this report. Okay, just showing everything, right? Their training phase, their GPU utilization, their testing phase, right, their power users and everything, right? Now this I will personally be very happy if someone is showing me this report. Okay, because I can actually basically see all this batch file testing report as well, right? You can basically like share it here, so you can basically like publish the report from here and share it to someone else. Let's say if I wanted to share it on my mail, I can actually save it, right? So you can basically like share it and do the invitation and send it out, and then you can basically copy the link and create it. This you can actually like, it can easily be shareable to your peers as well, right? So in this way I wanted to show you about these things, right? That WanDB integration and other things. Okay, the system monitoring, the CPU power, the RAM used also telling, okay, the swap memory used. So these many analysis you rarely get some other platform. Okay, that is why like it's very good. So yeah, so this was my intention, just to show you that how good and easy it is to integrate both MLflow as well as WanDB into your projects. Okay, you can actually integrate both ways, because MLflow is most about like the saving the project name with a different artifact and see the result. The WanDB also does the same thing. Okay, you can basically like try to like use it some other name, other project name here. Okay, so let's say Ultralytics demo version. You can basically like change the project version, change the experiment name, and then again run the model with the multiple epochs, and you will also get the separate artifact of experiment name and their separate report as well, that can be easily be shareable, right? So that is the main intention of showing you the entire thing. Okay, so we have discussed today about the post training phase, right? That how do we actually like manage and see everything visually, right? So that basically you can basically surpass all these things into your ML pipeline. Okay, so that's it. So that's the end of this today's lecture, and let me know, so we will again move again to the next part of the series. Thank you.